Hi everybody, welcome to Test 1 review for ordinary differential equations. We will go through the list of the question, and on this side you will have uh, some formulas that apply to the problem, and on the top you will see the list of the problem that we will do. Anyway, let's start. Uh, the review have 26 questions, but we're not going to go through every problem, just some of them. Anyway, so let's start. The first question, by the way, it is a typo. This should be a cube. Right. So that is a cube. So that highest order of derivative is the third derivative. So it will be 3. By the way, that should be 3. Right. That's the first one. Next, number 2, rather simple. We take derivative and the second derivative and then substitute into the equation, and that should be equal to 0. And we assume that C1 and C2 are constant, so we have C1 and C2 are constant. So let's try that. So this is the function. We check derivative. Minus 5C2 sine 5x. And then check the second derivative. Will be another 5. Make it 25. Derivative of cosine is negative sine. And that 25 derivative of sine is cosine. Right. We have the second derivative. We'll put this second derivative into that, and then the original function into y. So we have negative 25 C1 sine of 5x minus 25 C2 cosine of 5x. So that is the second derivative. The original function is that. And obviously, if we multiply them out, this is equal to 0. So this is true for every x. So the answer is yes. This is the solution of the equation. Right. Pretty simple. On number 3, we will substitute the function first derivative, second derivative, and then we should be able to solve for m. We did one of this in class, I think. So we'll skip this one. Next, we're going to do number 4. Right. Number 4. It says that suppose the function is y equal to m x to the m power. Now we'll find m so that this differential equation is satisfied. Later on we'll we see that this is Cauchy-Euler equation, I think section 4.7. Anyway, so we have y equal to x to the m. The derivative will be mx to the m minus 1, and the second derivative m times m minus 1 x to the m minus 2, and then we substitute everything into the equation. So x squared, the second derivative is that, right, minus 7x. The first derivative is this, and then 15, the function x to the m equal to 0. Note that we have all of them, x to the m, x squared times x to the m minus 2, that is x to the m times m minus 1 minus 7x to the m as well times m plus 15x to the m equal to 0. All of them have x to the m power. So we'll factor it out. We'll have m times m minus 1 minus 7m plus 15 equal to 0. Now we want the equation to be true for every values of x. So if we choose x to be 0, of course this is true, but that doesn't work. We want the equation is true for every x. So in that case, this must be equal to 0. So in that case, it will be true for every values of x. So we have the equation m squared minus m minus 7m plus 15 equal to 0, m squared minus am plus 15 equal to 0. So m factor 3 and 5. So I have 3, 5. Yeah. So we just substitute the derivative, second derivative, into the equation, and then we solve it. Should not be a problem. Right. We did something similar to this in class already. So pretty much we substitute pi over 2 in for t for the function. That will be equal to 0. If we substitute the derivative at t equal to pi over 2, we should get 1. So that should be simple. I do the next to number 6. Right. Equilibrium values and determine which one is stable, which one is unstable. All right. So equilibrium, we need. By the way, this is an autonomous equation. So when we need this function only depends on y equal to 0 to find the equilibrium. So we let so obviously we're going to get plus or minus 4. I'll try to sketch this. Notice that this is the y values, which is the vertical axis. So we have two of them. One is 4 and one is negative 4. Let's see, that is 4. And is -4. So all we need to do is just pick a number above 4, in between -4 and 4, and then less than -4, and then we put into the function and see if it is positive or negative. So let's put number 5 in here. For y, in between here let's choose 0, and below here let's choose -5, and then we evaluate at this function. Let's do 5, 0, and -5. Now we evaluate the function. Put 5 in here, obviously it's going to be positive. Put 0 in here, it's going to be negative. And put -5 in here for y, it's going to be positive. So we have positive, negative in the middle, and positive. So pretty much, because the derivative equal to positive, which means it is increasing, and in between is negative, which means it is decreasing. Not exactly like that, it could be a little curvy, but that's the flow. And then -5 is increasing. So if we have the point in here, it will go toward -4. If we have a point in here, it will just shoot to infinity. So we will tell the pattern. So we can also write like this: positive is increasing, negative is decreasing, and positive is increasing. And we see that the flow of the function that approaching to the line of -4, so this will be stable, and that is x equal to -4, and this is unstable because it goes away from it. The function, the solution go away from the line, so that's what we have. Right. Right. Other method. Let's see it. Yeah. So that is the Euler method, and of course we're going to use this the calculator. So the Euler method for the initial values problem. By the way, I will do for 7. Right. Take a look at 7. We have the problem. This is the problem. So initially we have y3, y of at 3 equal to 6, meaning x naught equal to 3 and y naught equal to 6. This is our initialization, and h is equal to 0.2. Right. So the step will be as follows. So we said x naught 3, y naught 6, and h 0.2. We use the calculator for this. I need to zoom out on this one. Right. And after that, the recursion is xn equal to xn plus 1 equal to xn plus h. Just exactly like the formula says. Yn plus 1 equal to yn plus h of fxn yn. However, we know the function is going to be this, so we can write n plus 1 yn plus h times the function we can write 2xn yn minus 2yn, right? So we use this instead. Right. Now we put in the calculator. Notice that we're going to use this button right here, the comma, second parentheses will give you the curly bracket. So first h is 0.2, so 0.2, and we store this key into h. Right. Next we store x naught and y naught. We're going to store that into a list. 3 and 6. We store that into list 1, so we hit second L1. So 3 and 6. That is the values of list 1. Next we're going to do these two things. So first, notice that in this problem, if we use the calculator, every time we see xn, it is going to be L1, which means the first component of the list, and yn is the second component of the list. So every time we see xn, that's what we enter. So xn plus h, L1 of 1 plus h. Right. So that's the first step. That will update the list by adding h to it. Next is this. So second one, so that will be yn plus h two times L1. Let me change this so it's easy to see the whole sequence. I go to the classic view. I will have that. Okay, that first. Now, okay. So that L1 plus 1, which is xn, I'm sorry, plus h. Right. Xn plus h, and then yn plus h, and then times, so times 2 A1 at 1 times A1 of 2, so that is 2xn yn minus 2 A1 of 2, that is for y, and close, and we should close the curly bracket as well, and we'll store that into list 1. So we, after we do the list, then we update the list by that. So we have 3.2 and 10.8, right? So we have 10.8. Do hit enter again. We have 20.3040, so that look right. Then 0 again, 39.79584. So it's going to be 8. Yeah. Pretty much in yeah. Again, this is the recursion. Of course, the next problem we can do the same thing. Dx here is going to be h. We just keep doing that until we have x equal to 1. We don't need to do that. Right. Next is the separable equation. So for separable equation, we just need to have x and dx on one side, y and dy on one side, and integrate. So let's look at number 9. Actually, 9 is too easy. Let's go to 10. Right. So we have this problem. First, we need to get y by itself and x by itself, and then we integrate. And to scramble, we divide y squared. We have 1 over y squared dy, and then move the dx over. So that is separable, and then we integrate both sides. Integral of e to the 7x is 1 over 7 e to the 7x plus c, and integral of this is y to the negative 2 dy. Integral will be y to the negative 1 over negative 1. Right. And we multiply negative 1 to the outer side, we will have y to the negative 1 equal to 1 over negative 1 over 7 e to the 7x minus c. So we multiply everything by negative 1. On both sides, that we do it. And y to the negative 1 is 1 over y. So just flip it both sides. We have y equal to 1 over negative 1 over 7 e to the 7x minus c. By the way, minus c or plus c, it doesn't affect much. It still is a constant. Yeah. Yeah. Right. Yeah, we can just leave the answer like that. Right. Let's take a look at the 11 as well. So again, it is also separable. So we scramble, get x and y on one side and y on one side. So we have 1 over y squared dy, 1 over x dx, and then we integrate both sides. Integral 1 over y squared, we already did that before. And 1 over x is ln of x plus c. Right. And again, we take the negative to that side. Right. And then we flip it. Because here we multiply by negative 1. So the negative 1 to this side. And we just flip both sides. Right. Almost there. We still have the initial condition of this. So which means when x equal to e, y equal to 2. So we have 2 equal to 1 over negative ln of e minus c. By the way, ln of e is 1. Absolute values of e is still e. So this is equal to 1. So we have 2 equal 1 over negative 1 minus c. Right? Right. And when we solve for c, so look like c will be just cross multiplying here. Forgot the 2. So cross multiply negative 2, negative 2, negative 2c equal to 1. So c equal to negative 2c 2c equal to negative 3. So c is negative 3 half. So we have y equal to 1 over negative ln x minus 3 half. Yeah, definitely we can just leave it like that. Or we multiply 2 top and bottom just to get rid of the negative. I mean, of the 2. Right, that will do it. I said we can leave the answer in this form. Right. So that is that. Right. Linear equation. Number 12, I will not do it, just write a few steps. First, to make sure that it has to be in the standard form. So we divide everything by x. So that cancels out. And so the standard form is dy over dx minus 2 over x y equal to 2. And this is p to the x. And then we integrate. Integrating factor for linear equation. Integrating factor is e to the integral px dx. So I'll let you do that. Right. Let's look at 13. Right. First, we have to scramble and make sure it is in the standard form. So we have derivative here, which is good. So let's keep it that way. Move this to the other side and make it equal to x squared. Right, just move this to that side and we have that. And also we divide by 3x everywhere. Because we need to have derivative by itself. Pretty much everything cancels out. Just have negative 3y. X squared, x cancel out, we have 1/3 x. Right, I have to write that in the standard form. Right. So course the 3 cancel out as well, so this will be 1. Sorry, and something didn't look right. Yeah, 3 and 3 cancel out. Right. So p of x is equal to -1. So we'll find integrating factor. Right. Right. So it will be e to the negative integral of -1 dx, pretty much e to the negative x. Multiply both sides. We multiply both sides by the integrating factor. It turned out to be a lot more complicated than it should be. Anyway, so the left hand side is the derivative of the product, and the right hand side is 1/3 x e to the negative x. Right. Integrating both sides. That is x e to the negative x dx. It has to be integration by parts. Ouch. Right. So take the 1/3 outside first. Integrating 5 parts, we have to have u and dv. So here will be uv minus integral v du. Right. Since u is x, so we have x. V integral of e to negative x is negative e to the x, negative x. V negative e to the negative x, and du, derivative of x, is just 1, so just dx. Alright, clear this out. We will have 1/3 negative x e to the negative x minus negative, so turn into a positive e to the negative x. Integral of e to the negative x is negative, so there will be 3 negative signs here, and that turned to be negative. And then plus c. C times 1/3 is still a constant c. Right. And then we divide by e to negative x on both sides. And then we just y, and e to negative x will cancel with e to the negative x inside, so we have 1/3 negative x minus 1 plus c divided by that, so e to the positive x. Move this to the top, it will turn to positive. Right. other than the integration by parts. This is pretty simple. Not that the integration by parts is any complicated. Right, that. What's next? Right. The next one will be similar, but I have to solve for the initial conditions. Right. Next, test for exactness. So we have exact equation is this. So let's look at 16. 16. So this will be m, and this will be n. So we find the mixed partial derivative. So we find my. Derivative of m with respect to y pretty much will be just this. So we have cosine of x. Derivative of cosine y is negative sine y. And then we find nx. Derivative of this with respect to x is negative cosine x sine y. And since they are the same, it is exact. Right, so pretty straightforward. For this problem 17 and 18, we'll have to do the same thing. Show that it is exact. And then if it is exact, then we will solve for it. Right. Let's look at 18. Oops. Right, 18. So this is m, and this is n. Right. So just take derivative. So m of y, and then n of x. Derivative of m with respect to y will be 2x minus tangent. Derivative of tangent is secant square. Right. Derivative of n with respect to x will be 2x. Derivative of x, so that one gone. So because they are the same, so which means the equation is exact. And the equation is exact, meaning that there exists the potential function. Means there exists a function of x and y such that derivative of x equal to m, which is equal to 2xy minus tangent y, and derivative of f with respect to y is n x squared minus x secant square y. Right. The method we use in here is successive integration. We have derivative of f with respect to x, so we'll integrate with respect to x. So first we integrate with respect to x. So we get back to the original function. Notice with respect to x, give you x squared. We have x squared y. That the integral of 2x, and then here we have a constant. So we're going to stick an x to it. And since we integrate with respect to x, should have a constant which depends on y. That is still the function fxy. So we integrate. Next we will differentiate with respect to y. Have derivative of f with respect to y will be equal to, we're using derivative of this, x squared minus x tangent y with respect to y will be secant square y plus derivative of y. And this we will let equal to n, and n is this. So except for that we just have x squared cancel on both sides, negative x secant square y cancel both sides. We have g prime equal to 0, which means g of y is just a constant. Now we know it is equal to a constant. We can just substitute that back in here, and we have the answer. The function is equal to x squared y minus x tangent y. Plus g y, which is a constant c. Or we should write in the equation x squared y minus x tangent y equal to c. We make this equal to 0 and then move the c over, and we have that. Right. So that is 18, exact equation. Right. Next is homogeneous equation. C, homogeneous equation. Right. Equation with homogeneous coefficient. So we will make a substitution of y equal to vx. So for homogeneous equation, y equal to vx. And when we make that substitution, I should be able to get back to a separable equation. What happened to the camera? Right, okay. Right. So if y equal to vx, then we take derivative. I think that is the autofocus. So we take derivative on both sides. We have x dv plus v dx. Right. So that is for dy. Now we substitute everything into this equation. We have 2x squared y squared. We're going to have vx squared there's no square here, sorry, minus x, y is vx, dy is this, equal to 0. So 2x squared y squared vx squared dx, x, that is y, that is dy. Right, multiply everything out. 4x squared dx, and this is 2x x squared v squared dx. And then this gives us x times x squared v x cubed v dv, so 3xv, and then dv minus xx vv, so x squared v squared dx equal to 0. Right, there's a bunch of everything have x squared in it or more, so we divide by x squared. Right, so we have 4 dx plus notice that this term are like terms. We combine them, we only have x squared v squared, but we divide by x squared, so that's just v squared left. Okay, so x squared gone, and then 2 minus 1 is positive 1, and then just that. Sorry, divide by x squared, so we just have xv dv equal to 0. Right. Keep the v on one side, the x on the other side, so I move this to the other side and factor out the dx. So we have that, and then xv dv to the other side, divide by 4 plus v squared on both sides, so we and move the x over. By the way, this is a separable equation already. So we move the x to this side, and we move the v over 4 plus v squared to that side. So x on one side, v on one side, then we integrate. Will give us 1 ln of absolute value of x plus c, and this we're going to use a substitution. Let that be u, so we have du is 2v dv, and du over 2v is dv. Substitute everything in, including that for u and that for dv. Anyway, so v over, this is u, and dv is du over 2 v. V and v cancel out, so ln of x plus c equal to 1/2 1 over u du. Right. So ln of x plus c equal to 1/2 ln of u. Right. We only need one constant. Right. Let's multiply the 2 to that side. By the way, u is 4 plus v squared, so let's substitute that back in first and multiply the 2 on that side. Yeah. So 2 ln of x plus c ln of 4 plus v squared. Right. And we'll raise both sides to the power of e. right now space. So I try to write the answer, continue the answer from to here. Right. When we raise that before, so it will be e to the 2 ln of x times e to the c. E and ln cancel, and here will be absolute values of 4 plus v squared. So the 2 here will take inside. So I have e to ln of absolute of x squared e to the c absolute values of 4 plus v squared. Right. E and ln cancel, we have absolute of x squared. Let's put e to the c in front of it. Now, to get rid of the absolute values, by the way, the square guarantee that is going to be will carry the positive sign, so we just have e to the c x squared. Next, to get rid of absolute values, it's going to be plus or minus. So if we remove the absolute values here, it will become plus or minus. And this still is a constant. So I just write that as a constant c times x squared equal to 4 plus v. If y is equal to v times x, so v is equal to y over x. So we have that. And then if we divide by multiply x squared on both sides, so we have cx to the 4th. So I multiply x squared for x squared plus y squared. Yeah, and can leave the answer like that. So yeah, a little bit long, but the concept is not too much. Y equal to vx, and then solve for dy. When you substitute in, and there should be something to cancel out, and then you should have a separable equation, just as the flow chart on the formula page. The equation in homogeneous equation, if we make a substitution like that, then you should have a separable equation. Right. So that is a substitution. That is the answer. Next, I think we did something like 20 in class, so we're not going to do that here. We'll do 21 instead. Right. 21 to 22 is Bernoulli equation. Actually, let's take a look at 22. Right. Bernoulli equation. So it is this. Right. As we see that, it looks like the standard form of the linear equation. Look exactly like that, except for the y to the n. So we should change that to the right form. So I will divide by x squared on both sides. By the way, this problem could be long, so let's divide that into the base into 2. Right. Let's divide by x squared on both sides. 3x squared actually. So we get the standard form y prime minus 2 over 3, actually x at the bottom, equal to 1 over 3 x squared, but there's a y here of course, then y to the negative 3. Right, so we have to write in the right form. Next, the Bernoulli equation, the substitution is this. V equal to y to the 1 minus n, and in this case is negative 3. So substitution, let v equal to y to the 1 minus 3, so it will be y to the 4th power. Right, and then we can take derivative. So v prime, or we write dv over dx equal to 4y cubed dy over dx. This is the chain rule. So if you want, we want dy over dx, it is going to be 1 over 4 y cubed dv over dx. Actually, let's move the y cube up. So let's say dy over dx is 1 over 4 y to the negative 3 dv over dx. Right. Now let's substitute that back into the derivative. See what happened. 1/4 y to the negative 3 dv over dx minus 2 over 3x times y right. What we see here is that this, if we make the substitution, we should get back to a linear equation, and the linear equation doesn't have the y in this side. So what we do here is we have to multiply by y cubed to get rid of this. So that will turn into the linear equation like that on the right. So let's multiply by y cubed. Actually, we multiply by 4y cubed, so get rid of the 4 as well. Right. So we have dv over dx, and we multiply by 4, give us 8 over 3. Still have x at the bottom. Y cubed times y will be y to the 4th, and we have 1 over 3 x squared only. The y to the 3rd cancel out with the y cubed. We still have 4. So multiply 4y cubed on both sides. Y cubed cancel out, and the 4 on top. So that's what we have. Right. And it's always the case when we do that, this should be equal to v, and it is. So we have dv over dx minus a over 3 x v 4 over 3x squared. This now is the linear equation in the standard form. So what we have here is p to the x is negative 8 over 3x. This looks familiar. Maybe we did this in class already. Anyway, so integration factor so will be e to the negative a over 3 ln of x, and we take the negative 8 over 3 inside. E ln cancel x to the negative 8 over 3. Note that since the top number is even, so that line raised to an even power, so the absolute value is not needed. So we just have that. We can multiply that both sides. Right. 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 Regardless, the left hand side we just have the integrating factor and then just the variable, the dependent variable, derivative. And let's simplify this first. 4 over 3 that is negative, so we move that to the bottom, and we have a over 3 plus 2. Or move x to the top to negative 2, so x to the negative 14 over 3. Look a little strange. Right, now let's integrate. Integrate both sides to get rid of that derivative. So x to the negative a over 3 v integral of that will be negative 11 over 3 negative 11 over 3 plus c. Right. So we flip that 3 and 3 cancel out. We have 4 over negative 11 x to the negative 11 over 3 plus c. And to get rid of x to the negative a third, we multiply x to the 1/3. Wait, so we multiply x to the a third 11 over 3 multiply 8 over 3, so that is negative 11 over 3 minus 8 over 3, so that is negative 3 over 3, so this is just negative 1. And then c times x to the 8 third. So actually you can move uh, x to negative 1 down to x, then c x to the 8 third. And then v you can write as y to the 4th power. Okay, check the answer. So yes, that's what it is. You can take the 4th root on both sides. Yeah, so that's the complete problem. So once again, the Bernoulli equation, we make a substitution of v equal to 1 minus n, that to be, in this case, take derivative, because we need to know the derivative of y with respect to x, and then we convert that to v, so we can substitute into the equation. Substitute into the equation, and we have to divide the y to negative 3 on both sides, or multiply by y cubed. Bottom line is we try to get rid of the y on this side, because the linear first order equation, there's only x on this side, on the right side. So when we do that, it shall happen that is also equal to v, and so we have a linear equation, and the rest of the linear equation, we just do that, and we end up with this equation. Right. Right. 23 and 24, the type of question are similar. However, 24 we have to do a lot more, so I will go with 24. Right. Try raw tank here. It is maybe a long problem, so we do the problem down here. Right. And summarize. It is the tank that is half full. Alright, so half full. And of distilled water, so we'll talk about that later. Alright, at time equal to 0, a solution of 2 pounds per gallon. So we have enter at the rate of 4 gallons per minute. So we have the rate of 4 gallons per minute. The concentration is 2 pounds per gallon. That's what it coming in. And the solution coming out, we have the rate that coming out at 3 gallons per minute. And the concentration, this is going to be a bit complicated. All we know is that it's going to be equal to whatever the salt over the volume. Right, so let's start. Let x of t be the amount of, we have of concentrate, so like salt in this case, be the amount at time t. So in this case, the amount times t will be x of t divided by the volume. The volume in this case is complicated. What we have is, let's look at the initial condition. So we have a tank of half full of distilled water. So at t equal to 0, the volume is half full, meaning the volume is going to be equal to 50 gallons of pure water, meaning originally there's no concentrate of pure water, so it will be just that. Right. Now, notice that we have 4 gallons flow in and 3 gallons flowing out, meaning every minute the volume is increased by 1 gallon. So I will write something like net volume. We have plus 4 in and minus 3 out, so it will be plus 1 gallon per minute. Since we start 50, so we write x of t, we start 50 plus 1 minute, plus 1 gallon per minute for every minute. So you have x over t over 50 plus 1 times t, or just t, because we increase 1 gallon every minute. So that's what we have for the volume. And with that we have the concentration. Right. Next we have the rate in. The rate is always the flow rate times the concentration. So the flow rate 4 gallon per minute. The concentration 2 pounds per gallon, and it cancel out. We have 8 pounds per minute. That is the rate that is coming in. The rate coming out is also the flow rate times the concentration. By the way, we do have those formula in the mixing problem down here. The flow rate is 3 gallons per minute. The concentration x of t over 50 plus t. Of course, that will be x of t will be the pounds per concentration, should be pounds per volume, so pound per gallon. The gallon cancel out, so that will be equal to 3xt over 50 plus t. The unit pound per minute. Right, and to get the equation, we're going to have the net rate is equal to rate in minus the rate out. Yeah, the problem a little bit complicated when we have the volume non-constant. Number 23 will be similar to that. So the net rate will be dx over dt. Rate in 8, rate out 3x of t over 50 plus t. Right, need to zoom out. Right. Now we have the equation. If we move this to that side, dx over dt equal to plus 3 over 50 plus t, x equal to 8. So if we write like this, definitely we have the linear first order equation, where this is going to be p of x. Right. So integrating factor By the way, when we have the equation like this, we also have the initial condition to go with it. So x of 0 equal to 0. Yeah. So this problem has the initial condition of that. The problem should have the equation with the initial condition. Right. Integration factor mu x equal to a to the integral of p of x dx. So mu of x equal a to the 3 over 50 plus t dt. Right. I skip a few steps in integration. This should be 3 ln of 50 plus t. Of course, you take the 3 inside. I zoom back in. Right. Now, first, t is going to be positive because t is time, and it is positive. Plus 50 is still positive. So we really don't need the absolute values. It cancels e and ln. So bottom line is we have 50 plus t cubed. And that is the integrating factor. We multiply that both sides. I hope we have enough space for this problem. Fifty plus t cubed. I write x prime just to save some space. And then we multiply 50 plus t cubed x equal to 8. 50 plus t cubed. That in green. Right. The left hand side is a product rule, derivative of the product. And the right hand side is just this. Right. Integrate to get rid of the derivative. Right. So 50 plus t cubed x equal to integral of this. Also substitution. I skip that step. Right. So we have this. A and 4 cancel out. So we have 50 plus t cubed x equal to 2. 50 plus t to the third plus c. If we divide by 50 plus t cubed on both sides, we're going to run out of space here. Hope you still can see it well enough. Right, so we have x equal to plus c over 50 plus t cubed. Right, so that is the solution. There's still a lot to it. First we have the initial condition x of 0 equal to 0. More space. Right. On the test, I will not ask you to solve the complete problem like this. More like 23 instead of this. Anyway, so if we put 0 for x and 0 for t, so we will have 0 equal to 2 plus c over 50 cubed, or negative 2 equal to c over 50 cubed. So c is equal to negative 2 times 50 cubed. Well, big number. So we have the equation is 2 plus negative 2 times 50 cubed over 50 plus t. Yeah, we put in this equation cube. Right. And finally, the question actually asks is when the tank is full, how many pounds of concentrate will contain will be in the tank. We have 100 gallons, and we originally 50. It increased by 1 gallon per minute. So of course, when it's full, it will be 100. So pretty much 50 plus t equal to 100. So when it's full, let me write it down. So it's full at 100 gallon, meaning 50 plus t equal to 100. So t is equal to 50. So we just need to know when t equal to 50, what is the amount of salt or concentrate left. So x of 50 equal to 2 plus negative 2 times 50 cubed. 50 plus 50 cubed. There's something. Never mind. Yeah, I know that there's something wrong here, sorry. There's a fourth here, so there should be a fourth. And there's missing a 50 plus t here. Right. So let's erase that. Right, sorry. It was t to the 4th and I forgot that. Right. Divide by 50 plus t cubed, so there's still one of them. So x of 0 equal to 0, meaning 0 equal to 2. 50 plus 0 so we have negative 100 equal to c 50 cubed. So C equal to negative 100 times 50 cubed. Right, should be that instead. Sorry. So the equation x of t equal to 250 plus t plus negative 100 times 50 cubed. Yeah, just fit. 50 plus t cubed. Right, and we'll do the same thing. The tank is full at 100, so it's full at 100. Meaning at 50 plus t is 100, so c is 50. So pretty much we just need to find the values of the function when t equal to 50. Right. So that is 100, 200. I will change that back to the math print. Right. So 200 plus actually minus. We're going to do the fraction 100 times 50 cubed over 100 cubed. So we have 187.5. That will be pounds of concentrate. Yeah. So that is a complete problem. Yeah, a bit complicated. But the fundamental of the mixing problem, we have a flow rate times the concentration give us the rate. The rate usually the mass over the unit of time that entering or getting out of a tank. And the net rate in minus rate out, and we have that. Right. I'll just keep that for a moment. And then the last one we'll do 25. Right. An endangered species of fish population characterized by that. We don't need a lot of space here. So I zoom back in. Right, population of 6 years ago was 1600. Only today 900. Once the population dropped to 100, it cannot go back. Right. So let's summarize a few things here. We're going to have time, and we're going to have the population will be the amount given by that. Right. 6 years ago it was 1600. So let's say 6 years ago, let's consider that t equal to 0, which is 6 years ago. We just need to denote that. Uh, 6 years ago. Today, which means 6 years after 6 years ago, so it's going to be 6, meaning today. The time is going to be equal to 6 years. And then, so 6 years ago, it is 1600. Today, 1900, 900. At what time it will go to 100? Right. So pretty simple. We have those data summarized in that. The next one, it will be very useful if we can summarize similar to that. Right. So first we look at this equation. and we put everything we know into this equation. We have 1600 equal to, we don't know this, we don't know k, we know t is 0, and e to the 0 power is 1, so that is 1. So pretty much we have a naught is equal to 1600. That's the first thing we can get from the problem. Next, this. Let's put everything we know. 900 for the population. A naught, we already did that, 1600. K, still don't know K, but we do know 6 years is time. Alright, now we have one equation, one variable. We should be able to solve for K. So we do that. Let's divide by 1600 on both sides. Divided by 1600. We have 0.5625 equal to e to the 6k. And to get rid of the e, we can check the ln on both sides. Right. And then we solve for k, and so we take that divided by 6. Right. The fraction alpha y equal to, and then hit enter. We have a fraction of ln 0.5625 divided by 6 negative. The rate is negative, meaning it is decreasing. So that works out. That makes sense to say that. So that is about 9% decreasing. Right, that equal to k. That's what we get. And for the last part of the problem, let's substitute everything we have. Right. We know the population is going to be 100. Initially 1600. E, the rate we know is going to be this. And t we don't know. So pretty much similar to this. Divide by 1600 and then check ln on both sides. Uh, 1 divided by 16, 0.625, 0.0625. And then we check ln on both sides. Right. And so for t, so we take ln of that divided by that. alpha y equal to ln 0.0625 divided by negative 0.0959. We have about 28. So let's round that to 29 years. But that is 29 years from 6 years ago, so 29 minus 6. So pretty much about 23 years from today. So pretty much we can summarize that, and the equation for exponential growth or exponential decay is going to be this. It's going to be that. Growth is increasing, decay is decreasing. On this one it is decreasing, so it is decay. So I will summarize number 26 in a similar fashion. We're not going to do it, but just get the idea. So first, we still have 8 equal to a naught e to the kt. That is the same as exponential growth or decay, still the same function. What we have here is actually x equal to x naught e to the kt. That is exactly what we have here. So we have t and x naught. Let's just say a equal to a naught e to the kt. Right. Just put some information in here. What do we have? So we have half-life is 5700, meaning it will take 5700 years. The amount will be equal to 0.5 of the original amount. That means half-life, half of the original amount. Next, if it is found that 68.5 of the count 14 is still in the matter, so we said what happened when a equals 0.685, that's 68.5% of a naught. What will be the time? So we do pretty much similar to it, by the way. So yeah, one more time. Right. So first, from here, I will not do a complete problem, but have 0.5 a naught equal to a naught e to the k, don't know k, but do know t. So from this equation we can solve for k. And after that, for the next part of the equation, you have 0.685 a naught equal to a naught e to the k. We know k from that step, so put that in here for k, and then t we don't know, and then we solve for t. And of course when we solve this problem, the first step is divide by a naught, and then check ln. So the step will be pretty similar to this: divide by the constant, the coefficient in front, and then check ln, and then solve for the missing variable. So this problem kind of the same idea. Even though one of them is increasing, one of them is decreasing, it's still characterized by this function. And if it is increasing or growth, the k is positive. Actually, both of them decreasing in this case because the rate is negative. This problem should be negative as well. Anyway, I think that will be it. To be enough for review for the test, and I hope it helped you to prepare for the test 1. As always, thanks for watching.